As you see here from this video, there is a racing car with an orange color. Car, it's an object, has a specific mass. Okay, this car supposed to be due a motion. So if we need to talk about momentum, so momentum related with motion. So when the object is moving, has a specific velocity, and any object has a specific and constant mass. So if I need to talk about momentum, momentum contains mass and velocity. Means momentum talk about the motion, the amount of the motion of that object. So the question here, if the object at rest, zero velocity, has momentum or not? Who can answer this question? Hello?
It has no momentum.
So no motion, no velocity, no momentum. There is a velocity, there is a motion, there is a momentum. Okay, for any velocity, we have been changing our velocity depend on our situation. If we talk about this car, it can start it from the parking, which is the velocity of the car, 0. After that, the driver accelerates the car to take the car to the road and start moving. And start moving with the velocity equal to 80 kilometers per hour. So what is the driver did? Change the velocity from initial, which is 0, to the final, which is 80 kilometers per hour. That means the momentum will be changed also. So I can say the change of the momentum depends on the change of the velocity. Okay? Okay. Okay, now can you open your notebook? So we need to write the lesson name, momentum and impulse. And we need to write the formula of the momentum. Momentum, as you see here, it's equal the mass, which is measured by kilogram, multiply the velocity, which is measured by meter per second. So the momentum, which is P, equal mass multiply velocity, which is kilogram multiply meter per second. So to make this formula easy for me, I will use this triangle, P at the top, and after that at the base, put a line over here and write mass multiply velocity. So if I need to find the mass, it will be momentum divided by velocity. If I need to find velocity, it's momentum divided by mass. If I need to find momentum, mass multiply velocity. So what is the formula for what is the unit for the momentum? It's kilogram multiply meter per second. Did you write this formula, please?
Yes.
Yes. Okay, I will move forward. Okay, let us start solve this example together. A car has a mass of 1,000 kilogram and it's not moving. What is the momentum of the car? Okay, who has an answer? How much the velocity if the car is not moving?
Miss zero.
Zero. So from the formula of the momentum, you have to multiply the mass, multiply the velocity. So 1000 multiply 0, I will have a 0 momentum.
Zero.
Yes, thank you. Okay, let's go to another question here. He gave you a specific velocity. If the same car with the same mass, 1000 kilogram, okay, and it's moving at a 20 meter per second, okay, calculate the momentum of this car. Actually, we will go to the same formula, P equal, who can tell me what we have to do?
Anna.
Yes.
Nada.
Yes, Yanada.
And then so it's gonna be P
Equal.
بعدين تحت شو equal?
The formula P equal what?
Okay. Mass times velocity.
Yes.
اللي هو بيكون 20 times 1000.
Yes.
Which will give us 20,000 kg meter per second.
Multiply meter per second. Yes, here, because there is a velocity, so I will use it to multiply by the same mass to have a new momentum for the car when the car starts moving. Okay, so it will be 20,000 kilogram multiply meter per second. Okay. So we'll stop here. This is another part. We'll go to the presentation again.
مسها وايد أسهل عن الكبلر.
ما هو لسه احنا ما دخلنا في كل ما تعقمنا، هو اسهل بس ما تعمقنا لسه بس
أنا الكبلر للحين ما فهمته.
انتوا عندكم تيست تيوزداي في ريفيجن مانداي كل واحد يحضر اسئلته، بس خلوني اسكر وارجع ادخل. سوري. For Rauda, for Kepler needs from you to save to remember the formulas. It's no more than formulas. يعني ما في فد أفكار يعني.
مس إنزين عادي تحطين الفورميلا ليست.
الفورمولا ليست هحط لكم، هبعث لكم نوتس على كبلر، هبعث لكم اياها من اسكر، كل ملاحظات، وكمان study that so we can one day discuss any question you need or if you need me to repeat something, okay? So to be easy for you on Tuesday, don't worry. الله. زين. نجي. Now, so today we need to continue with the momentum and impulse. If you need to find the relation with the impulse, which is force, and the momentum, this equation can connect each of them. How? When a net force, when I have a total force, acts on an object, the impulse of the force, the impulse, you know what is the meaning of impulse, right? Is equal to the change of the momentum. So the impulse, it came from the total. This means this is the net or total. Okay, the net force multiply with the time equal the same mass multiply with the change of velocity. If you have one velocity, you will say equal mass multiply velocity. If you have two velocities, so you have to repeat it final minus initial. Then, so I need to find or to check some real examples to understand why the force multiply time it's the same or can be equal to the change on the amount of motion. Let's look to this real example from our life. This track, as you see on the right side, there is a big track. As you see on the left side, there is a guy moving with this skater. Okay, a track is rolling down a hill. Then a roller skater with the same speed. So what the picture show you, there is a same velocity for both, equal. Okay, the track with guy with the skater moving with the same velocity. He's asking me which one has a greater momentum. Which one has greater momentum? And don't forget, both of them have the same velocity. Both of them has the same velocity. Who has an answer over here? But wait, because I didn't start recording this. Wait. No, it's recording.
It's recording.
I thought I didn't. Okay. Now, who has more momentum? Don't forget, we have the same what? Same speed here and here. So let's remember together the momentum. The momentum depends on two factors. Vectors. What are they? The mass
with velocity.
Velocity. If the velocity equal, so forget the velocity. What you have to use? You have to use the mass to compare because the velocity are the same. So which one has more mass? Is it the skater or the guy or the track?
The track.
The track has more mass, which means what? Has more momentum or not?
Yeah, it has a greater momentum.
Yes, it has.
So this is why the track will has more momentum because of the more mass, regardless the velocity. Okay, so the momentum depend on two factors, mass and velocity. One of them should be constant. Okay, now it's a practical examples from our real life. Why it's the impulse equal the change of the momentum. Then here he's telling you apply a force for a long time can generate momentum. How? For example, here follow a golf, swimming, or hitting a baseball, catching a ball. Let's see here. For golf, this player will what? Will use the stick here to what? To hit the ball with the force for a specific time, and the momentum will be generated because the ball will start moving with the velocity. That means the hard or the strong force the player applied on the ball, which is caused to generate the what? The momentum. And here, catching the ball moving with a specific momentum because it has a velocity and mass. After that, the guy will catch the ball with the force and a specific time. Okay, so these two magnitudes supposed to be equal. We need to see that in another example. First of all, we need to know the exact formula. The change in amperes, اللي هو force multiply time, it's equal to the momentum. How is that? Look at me. If the 100, the amperes supposed to be 100, also the momentum supposed to be 100. تمام? So that's mean if the force 50 لازم التايم يكون 2. يعني big force short time, and the opposite. If you have a small force, you have to make this time long. Then for the same principle, you have to make طبعا الماس هي constant, you have to make a proper velocity to make also the answer 100. Then, how is that can affect in our real life, and how the scientists use this in the car exactly to avoid accidents? Not to avoid accident, to save the life of the driver during the accident. Can you see this photo at the end, at the middle of the end of the page or the end of the slide? This photo. This is an example when the driver moving with the car, then with a specific momentum. يعني شو? The velocity multiply mass and the momentum, and suddenly had an accident. So automatically his body will hit, and his face, his head will hit the steering. So if he's moving with a high momentum, means high velocity, he will push or will hit the steering in very short time and with a very high or big force. So maybe he will destroy his head. So to keep this driver safe during the accident, what the scientists or the people who made this car did, can you see this? This is the airbag. Airbag, it's a design in all the modern cars. When there's accident happened, this balloon will be opened immediately. Why? This is like a from air, which is can give your head time, more time to hit the steering. يعني instead of hitting the steering in 1 or 2 seconds, it will keep you take more time to hit the steering during maybe 7 or 10 seconds, which is keep your head safe because it's reducing the force. How is that? Go back here. Go back here. Did you remember what did I say? I said, wait. I said, if I need to make the momentum 100, I work on these two factors. If I need to make this small, يعني 2, I should make the time 50. So to reduce, because there is inversely proportional. Inversely proportional means if you increase the time, the force will be decreased automatically. So the scientists use this relation to keep the driver safe by increasing the time to make the force less. So if you go back to the airbag did what? Increase the time. Give your head time to hit the steering. That means we reduce the force. And in another real example here, the bungee jumping. Bungee jumping, and we talked already about airbag. Bungee jumping, this rubber bolt connected to that person before jump from a specific height. Okay. They connected or linked this bolt to his leg. Why do you think they did this? Can you compare this with airbag and tell me why they did this? What did you expect it? Hello?
Yes, Miss.
Who has an answer?
Me.
Yes. Why
They,
the peoples did this? Who created this game?
because if he wasn't connected to something, of course he'd fall off.
So the peoples who need to kill themselves, they jump from a high tower to the air. They will hit the earth in very short time with the high force. Okay, so they have a high expectation to die. But here, to avoid that happened and to keep him safe, they connected his body with a belt, which is give him more time before hitting the ground. So he will reach the ground with a low force and a long time. Okay, so each of these two cases are working on the same formula. Why? Because he's moving in the air with the momentum. So we need the impulse to be equal to the momentum. We cannot change the value. In total, we cannot change it, but we can change the time to be more than force and to have the same total. Okay, so in this case also, if we use the parachute, it's also, as you see here, from the last left image downward, you can see the parachuter also uses the parachute, which is also increase the time and reduce the forces to avoid breaking his leg when he touched the ground. Okay, this is why, can you see here, delta T, it's written very big font, and force written in very small font. That means increasing T lead you to decrease force and keep people safe. Okay, did you get the concept?
Yes.
Yes. So this is why momentum, it's always related with the impulse. Okay. Now we have another real example. We need to talk about it. This is why we have to study physics, and this is for our life. Everything in our life related with physics. See here. I have a question here. Wait a minute. Why does a car is driven into a haystack at the same speed suffer less damage اللي هو here, less damage than the one driven into a brick wall or brick wall? So the person who hit this stick, he will suffer less than the one who hit the wall. Here, a big damage, while here, well, has no damage. Who can explain for me this phenomena depend on the relation between the momentum and impulse? Who can explain
Is
for
it
me why?
because the brick wall has more force?
In the first case, on the right side, there is a higher force than in the second. Why higher force? Why higher force? Who has an answer? If you have no answer, please tell me so I can. Hello?
Yes.
Why first case has big force?
Wow.
As I said before a while, when the time is shorter, the force is higher. Here will hit the wall immediately. There is no time taken spent before hit the ground, hit the wall, sorry. Here, there is time taken before hitting anything behind this stick. This is why here force very high. Short time, هنا time short. Okay? While here a time long. This is why different forces. Okay? This is why force here big, while there force small. Here force small. So everything, any accident depend on the time taken before hitting the assault object. So the crash depend on the time taken before hitting the wall or any assault object. Okay? Did you get me? Did you get me? Hello?
Yes.
Yes, we
Then-
get you.
Then another example here to focus on this point. Then impulse changing momentum. Okay. If the change in momentum occurs over, can you see here? A short time. Then the force of the impact large. Can you see here in which case you have a large time, a large force? The right or the left?
The right.
Yes, more crash means shorter time and larger force. Can you see? Big font force, small force, small font للتime. يعني small time or short time, big force create or produce a big crash. يعني the car didn't take time before hitting the wall. So here, as you see, the driver came with the high velocity. So at the end, you have two equal magnitude. الامبulse equal momentum. So if I need to reduce the force, increase time and reduce force. Increase time and reduce force. But in this case, no. The time taken short and the force was big. يعني if I need 100, I should make force 2 and time 50. But here, the time هو اللي 2 and force 50. Okay? This is repeated for the formula. Can you write this formula before move forward? Because we will not solve problems today. We will make it for next week. because we have only 3 minutes. Some student didn't do his quiz or her quiz. I will mention the names.
Which quiz?
Please, the first quiz we did it
Which bit?
with a relative. Some student didn't do. I will mention the names, so please contact me.
When do we have our next quiz?
Sure.
متى امتحاننا الثاني؟
Tuesday, test I said, and I said there is a revision on Monday. I said we will make relative and Kepler together, okay, and also on Edmodo. Then, did you write the formulas?
Yes.
Okay. Now this is the summary for today. So as
ردي بس بسوي كابتشر.
أبرار نايمة أبرار.
بس مو نايمة، موجودة حاطة ميوت.
لا أعرف إنك موجودة. زين.
لا نمت كفاية خلاص، صحصحت الحين.
كويس. I'm still sleeping. زين. The summary is, as Newton combined the ideas with the velocity and the mass, and we call it what? المومنتم. يعني المومنتم هو عبارة عن الموشن. Okay? This a motion momentum we call it. So momentum, it's how much the motion the object has, as we said. And momentum, it's a measure of how much mass. So when you have two masses, large and small, you can compare. More mass, more momentum. Less mass, less momentum. At the end, if the object is stopped, that means you have a zero momentum. This is the summary for today. Okay? Have a nice weekend, and we finish our session for today. Okay?
Thank you, Miss.
Thank you.
Thank you,
Miss.
Miss.
Bye.
Have a nice day.
Bye.
Now,
Stay safe. I love you.
thank you. Inshallah, stay safe. Be away from Corona. Thank you.